In the last video of this lesson, we're going to look at how you would plot a set of points and fit it to a trig function. And there is actually a sign regression on your calculator. If you go into the calc menu, it's it's letter C. But we're going to summarize what we've learned by looking at how we would do this manually. First thing we're going to want to find is the maximum and the minimum of this data that's given to us. We've got the day numbers and the high tide for each day. And it appears the minimum high tide would be, let's see, we got 23, looks like around 23.3. So the minimum would be 23.3, and the maximum, anything above 20, it looks like 28.0 on day 17 is our maximum. So now this is going to tell us a lot about our graph. So we can choose a sine or a cosine function, but let's just kind of draw one here. I'll draw a cosine function. If I have this function here, note that the amplitude is essentially going to be half the distance between your maximum value and your minimum value. So the amplitude, we're going to take 28.0 minus 23.3, and that would be 4.7, and then half of that is going to be our amplitude. So we take 0.5 times 4.7, we get 2.35. So my amplitude is 2.35. And my vertical shift, which is actually denoted D, we haven't really called it that in the last video, but that is the number we're adding to the outside of the function. That vertical shift is going to be what comes essentially halfway between 28 and 23.3. So it's really the average of the two is what ends up being our vertical shift. And if I take 28 plus 23.3 divided by 2, I get 25.65. So now I've got two key features of my graph. Now all I need is the phase shift and also my variable b that's going to multiply by the x. So in order to find b, let's first find the period. Now remember, the period is what one full cycle makes up. So if we look at the graph, half a period would be from the maximum point to the minimum point. And if we doubled that, that would get us one full period. So the distance from the maximum point to the minimum point is going to be wherever we had 23.3, which is 10, and our maximum was 28. So half of our period is the difference between 10 and 17. So what I'm going to do is I'm going to take 2 times that difference. So 2 times 7. So the period is going to be 14 days. Every 14 days you should expect another cycle. Now we also know that the period is equal to 2 pi over that variable we're looking for, b. So we know 2 pi over b equals 14. So therefore, if we multiply both sides by b, 2 pi is equal to 14 times the absolute value of b. And so therefore, the absolute value of b is going to be equal to 2 pi over 14, or pi over 7. Finally, if we're choosing to use cosine, we know cosine hits its maximum value at 0, whereas our graph hits its maximum value at 17. So that means our phase shift is 17. Recall that the phase shift is also equal to negative c over b. So therefore, 17 is negative c over b. We decided that b was pi over 7. So negative c over pi over 7 equals 17, which means that negative c equals 17 pi over 7, or c equals negative 17 pi over 7. Now we have everything we need to construct our function. We found that a was 2.35, so when I write this out, I'm going to have y equals 2.35, and I'm using cosine as my trig function. You could use sine or cosine. It would just reflect how your phase is shifted. So we have cosine, and then we're going to have b times x. So pi over 7 is our b value, times x. And then our phase shift ended up being minus 17 pi over 7. And then finally, our last value is that vertical shift we found, which we're going to have to add 25.65 to translate into our values. And that's how you find the function based on sinusoidal data. One thing I didn't mention is that you probably want to scatter plot this just to make sure it does fit that periodic nature. And whenever you get something like, I'll show you here, something that looks like this, you see it's kind of periodic in nature. That's when you're going to be able to use a function such as this to represent it. So here's one for you to try on your own. See if you can gather some clues to help you figure out, looking for that maximum and minimum, how you would represent this function.